today's lesson, we're going to use the laws of exponents that we already know to help us with the laws of logarithms. And it's going to be a nice throwback to Algebra 1. In fact, my Algebra 1 students are taking a quiz on this stuff tomorrow. Anyway, so remember, if you are multiplying powers with the same base, you add the exponents, right? But with logarithms, we're going to relate this the same way that we do before. If we were to think about b to the m and b to the n, you would add their exponents, right? So if we were thinking about logarithms, let's do an example. So if we had log base 3 of 7 plus log base 3 of 4, what that's really saying is we're going to work our way backwards. So if you think about this, we're multiplying expressions, we added the exponents. Here it's sort of like we're adding exponents, so let's work backwards and multiply. It's going to be a little funky. So it's sort of, like I said, like working backwards instead of forwards. Before, we combined our bases by adding our exponents. Here, remember the answer to logs are exponents, so to work backwards, if we're adding two exponents, we would have to work backwards and multiply. It's a little funky. It says express log base 6 of 4 and log base 6 of 9 as a single logarithm. So if we are adding logs, the rule is that I have to multiply. So I would have log base 6 of 4 times 9, which gives me log base 6 of 36. Now, is this something I could simplify? I think it is. So remember, if 6 is my base, what's my exponent to get me to 36? What would x have to be to get me to 36? 2, right? So my answer here is 2. It's some tricky stuff. I think this next one's a good one because it involves fractions. It'll be good practice with this idea of negative exponents here. But here, my base is 1/3. And in order to combine logarithmic expressions that are being added, I need to multiply what's on the inside. So 27 times 1/9 is 3, correct? And personally, I think it's helpful to write this in exponential expression. So 1/3 to what power gives me 3? Well, aren't these the same value just flipped? Right? These are the same value. It's 3 and 1/3. They're reciprocals. How do we flip something with an exponent again? It's got to be negative. So in this case, you're just going to have x equals -1. You guys have questions on any of those? Okay. We can combine logarithmic expressions. So using that similar concept, if we were dividing powers, we would subtract the exponents, right? So if I were to do something like log base 6 of 42 minus log base 6 of 7, in order to combine these things, I actually have to divide 42 by 7, which gives me 6, right? So what this is really saying is 6 to what power gives me 6? Well, my answer would have to be 1, right? 6 to the first power would give me 6. Does that sort of make sense? Yeah. Okay. So in this case, if we were expressing these as single logarithms down here, I'm going to do like mini shortcuts. So if I have log base 5 of 100 minus log base 5 of 4, well, 100 divided by 4 gives me 25, right? 5 to what power gives me 25? My answer would have to be 2. Right? So if you were writing your answer in logarithmic form, I'm going to write this over here because I don't have a ton of space. You would write log base 5 of 25 gives me 2, right? So if they ask for your answer in logarithmic form, you wouldn't just write x equals 2. You would have to write your original expression and then your answer. Does that sort of make sense? Hopefully. Okay. This next one, you'd have to divide. 49 divided by 7 is 7. 7 to what power gives me 7? 1, right? So 7 to what power gives me 7? That answer would be 1. Do you guys have questions on combining when you're adding or subtracting logarithms? Okay. So we're going to talk about inverse properties of logarithms and exponents. So we talked about how addition undoes subtraction, square rooting undoes squaring, blah, blah, blah. So if you have a logarithmic expression, do you see how there's an exponential expression within this logarithmic expression? What happens here, if you have the base b and then you also have a base b within that logarithmic expression, do you see how they already sort of gave you the exponent as your answer? Do you see that? If you were to rewrite this, this is saying my base is 10. Here is my exponent. 10 to the 7th power equals my answer. Well, right? They already gave you your exponent. Does that sort of make sense? It's kind of funky. And then here, you have an exponential expression and a logarithm. You have an exponential raised to a logarithm. Those two things should cancel, and you're just left with x. Does that sort of make sense? It's sort of like a cancellation. The 10s cancel. Here, the log base 10 and the 10 cancel, and you're just left with a 2. Those two operations undo each other. So I want to have you think about it this way. This setup here, it's saying log base 3, so 3 to the x power gives me 3 to the 11th power. That should be pretty easy to solve, right? Do you see how they have the same base? So 3 to what power would give me 3 to the 11th power? Well, wouldn't that just give me 11? Right? Hypothetically speaking, that would make sense. The way I like to think about these is you're doing 5 raised to the log base 5 power. Here's how I show my work. Those things cancel. My answer should be 10. It's supposed to be a base 5. Good question. That should definitely be a base 5. I don't know what happened to my little subscript there. What a bummer. Why isn't there a subscript written in part C? What is the base in this question? If there is no base here, then it's an imaginary 10. And when that happens, you have base 10 and an exponential 10. You're just left with your answer is that exponent. So whenever you have an exponential expression and a logarithmic expression with the same base in the same expression, they cancel each other out. Does that sort of make sense? It's kind of a funky concept. It's kind of like doing 3 divided by 3, right? It cancels. Yes?
Well, how come I see
So whenever there is no base, it's an automatic 10. The 10 is meant to be, it should be written with like a little space. This is meant to be the answer, right? And there is nothing here. That was the idea. There should have been like a little space there. Does that make sense? Okay. Another thing we need to talk about is most calculators only use logarithms in base 10 or base e. There are new calculators like these yellow ones where you can change the base to whatever the heck you want it to be. But not every calculator is that fancy. These ones cost $200, so not everybody can use those. So we do need to know how to change the base to be what we want it to be, okay? You can change a logarithm to one base in a logarithm with another base with the following formula. It's a little funky, but do you see how you have log base b of x? Do you see how this number goes on top? The base goes on bottom. So once again, the base goes on bottom, and then the x goes on top. And I am hopefully, with these examples, going to show you how that makes sense. Hopefully that will make sense. So if I have log 8, so remember that 8 went here and the 4 went there, why did they choose a 2 to put here? Why did they choose a to be 2? Why do you think 2 was that base that they chose? Why? Yeah. Doesn't 2 go into both 8 and 4? Right? But 4 to the second power would give me 16 instead of 8, right? So 2 is a multiple . So if I'm looking at this exponential expression here, and I think this is a little tricky, right? Now you can see why we're spending 2 days on this, right? I have to put the base in the bottom. So I have a log, that base of 32 goes in the basement, so in the bottom. And that log and the 8 go on top. What should I choose as my base now, that new base? So my first instinct is 4 goes into both of those, right? But 4 squared gives me 16, not 8. Wouldn't 2 work? 2 to the third power gives me 8. And then, so you have to think about 2 to what power gives me 8. And then here, 2 to what power gives me 32. Right? It's a little confusing. Two to what power gives me 8? 2 to what power gives me 32? There's my answer. Right? Another way to write this, once again, another way to write this, let's rearrange this for a second here. If we have log base 32, I'm having you think of this in 2 different ways, right? So we did the change of base formula to help us find this answer. Here's the other way. Remember, if we were to write log base 32 of 8, we would set that equal to x, right? So if we were to write this in exponential form, that would be 32 to the x power gives me 8. Now, what in the world, right? That's weird. So what you were going to do here is change these, and it's getting into the same idea as what we have written here. So 2 to what power gives me 32? That would be 2 to the 5th power, right? 32 is the same as 2 to the 5th power, and 8 gives me the same as 2 to the 3rd power. So once again, you can choose either method, right? But here, power of a power tells me I multiply my exponents, so I would get 2 to the 5th power